Welcome to week number 3 of the virtual end-of-course exam boost camp for Algebra 1. This week's topic is equations and inequalities. Before you proceed with this video, you will need to have printed all of the note pages. That way you can write on them as I do them in the video. If you have not yet printed those pages, please press pause, proceed to print the pages, and then return to the video. After you complete the video and the practice problems, you will submit the notes and the problems to your teacher. Please refer to your teacher's specific directions and deadlines so that you know when and how to submit these. Let's go ahead and get started with week 3. Kendra has a babysitting business that she earns $6 per hour that she babysits. She already has $50. She wants to earn enough money to buy a new phone for $350. We need to write an equation that represents how many hours she needs to babysit to earn the money to pay for the phone. We know that we're writing an equation here. After we write the equation, we need to identify how many hours that she needs to work. So I know that her total amount she needs to earn is $350. I typically place that on the right side of my equation. Next, I need to identify my variable. My variable is going to be X or H for hours, and it's going to represent the number of hours that she babysits. I'm going to go ahead and use X since that's what we typically use in algebra. Now I know that I'm going to have $6 for every hour that she works, and we need to also include the $50 that she has that she's already saved. So this would be my equation, $6 times each hour that she babysits plus the $50 she's already saved needs to equal $350 so she may buy her own phone, her new phone, I'm sorry. So now we need to decide how many hours she needs to work. So I'm going to go ahead and solve. Remember, when you're solving an equation, it's the opposite of order of operations. So we must undo addition or subtraction before we do anything with the multiplication or division in most situations. So I need to subtract 50 from both sides. These are inverse operations, so the opposite of adding 50 is subtracting 50. That's going to leave me with 6x on the left, and 350 minus 50 is 300. Now the last step, I have 6 times x. The opposite would be divide by 6. And I'm left with x is equal to 50. I need to answer my problem in context to the question. The question wants to know how many hours. So my response is 50 hours. Kendra needs to babysit for 50 hours. I'm going to go ahead and check my answer just to see if it makes sense. $6 times 50 hours plus the $50 she's already made should equal $350. So 6 times 50 is 300 plus the $50 she's already made. And yes, I see that 300 plus 50 is 350. So your solution here would be 50 hours. Number 2, another equation. We need to solve for the letter or the variable a. So let's get started. The first step, if possible, is always to distribute. So I see that I've got a 2 here that needs to be multiplied and distributed by every term inside my parentheses. So I've got 2 times 2a is 4a, and 2 times positive 3 is positive 6. Then I also have a negative 6 on this left, and I have a 5a and a positive 2 on the right. My next step is going to be combine like terms. So I need to combine any terms on each side that are alike. So I see here that I have 2 constants here. Those would be like terms. So positive 6 and negative 6 combined actually give me 0. That leaves me with nothing. So I'm just left, those cancel. I'm left with 4a on the left, and 5a and 2 are not like terms, so I cannot do anything with that. Now I need to move my variable to the left. As we know, we don't have to have the variable on the left. I just typically move it to the left. You could have moved the 2 to the right. There's several different ways we could have solved. So 4a minus 5a leaves me with negative 1a. And I'm left with 2 on the right. The last step, I can't be left with a negative variable, so I'm going to go ahead and divide by negative 1, and I'm left with a equals negative 2. I want to go ahead and just check my answer. So 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. 2 times negative 1 is negative 2 minus 6, which is negative 8. Then over here, I've got 5 times negative 2 is negative 10. Negative 10 plus 2 is negative 8. So I know that I've got my answer correct here with A equals negative 2. Sorry about that. Now I'm needing to solve this inequality. So remember, when we're solving inequalities, we're still following the same steps as we do with equations. The only addition is if we multiply or divide by a negative number, we have to flip that sign over. So again, just like with equations, I do the opposite of the order of operations. So I always want to begin with addition or subtraction and then move on to the multiplication or division. So I am moving my constant that's being added, I'm moving it away from my variable that I'm solving for. Now I have 2 times x, the opposite of that is divide, and I'm left with x is less than 1/2. Okay, let's go on to number 4. So again, we have an inequality here. So again, we're going to follow the same rules as when we're solving equations, with that one additional rule of when we multiply or divide both sides by a negative, we must flip our inequality sign. So as usual, I'm going to start with my addition or subtraction first. So I need to get rid of my constant first by subtracting from both sides. 14 minus 5 is 9. Now I need to divide both sides by negative 3. At this point, I've divided both sides by a negative number. So my inequality sign must flip over and become less than. 9 divided by negative 3 is negative 3. So I'm left with t is less than or equal to negative 3. Number 5, we've got a literal equation here. So we have v equals L times W times H. We need to solve for W. When we solve literal equations, we use the same steps that we solve to solve regular equations. So if I'm isolating my W here, I need to do the opposite operation of that's being used with the other terms or with the other variables or numbers on the right side with the W. So I see that W is being multiplied by both L and H. So I'm going to go ahead and divide by L and H. I must do that on both sides. Which leaves me with V over LH equals W. If you feel more comfortable writing it like this, you can. W equals V over LH. So there's your literal equation where we're solving for a variable with no additional values other than just variables in the problem. Here's another one. We need to solve for x. Okay, so I need to first undo any addition or subtraction that's taking place with my variable that I'm isolating. So I'm going to subtract the term by from both sides, and I'm left with ax equals c minus by. The last step, I'm isolating x, so I need to divide both sides by a. A divided by a is 1, so those cancel. I'm left with x equals c minus by divided by a. All right. Now we're moving on to the next part of this review for week 3. And now we're moving into systems of equations. That's where we have a system of equations is when we have 2 equations, 2 or more, that share the same solution. So there were different methods that we learned. We're going to start with the first one here, and that's graphing. In order to graph lines, we have to put them in slope-intercept form. When we have slope-intercept form, we can identify the slope of our line by looking at the m, and we can identify our y-intercept by finding our b value. So I see that one of my equations is already in slope-intercept form. I'm going to go ahead and work to get my other equation in slope-intercept form. So basically I am solving for y in order to get that y by itself. I need to move my positive 2x term to the right. So I'm left with y equals negative 2 divided by 3 is negative 2/3 x. 12 divided by 3 is positive 4. So my two equations, I now have y equals negative 2/3 x plus 4, and I also have y equals 2x plus 4. I'm going to go ahead and identify my slope and y-intercept here. And this one here is 2 over 1 and 4. So I'm going to go ahead and graph the line. I'm going to start with the first one. I'm going to graph that in purple. So remember, to graph a line, we plot the y-intercept, and then we move our slope, our rise, and our run. Plot the second point. You may find that plotting additional points is helpful to getting your line straight. And then once we do that, we go ahead and draw the second line. So let's start with a y-intercept of 4 and a slope with a negative 2 rise and a run of 3. Negative 2, run of 3. I'm going to go backwards, 2, run of 3. All right, so I'm going to go ahead and draw a line here. Try to get it. Nope. Let's try that again. As straight as possible. Okay. Let's go ahead and do our next one. We've got a y-intercept of 4. Sorry, I wanted you to be red. And a slope of 2, 1. So let's get ourselves a line here. And we can see that the place where my two equations in my system of equations crosses is at 0, 1, 2, 3, 4. So my solution is 0, 4. That would be graphing. The next method would be substitution. So substitution is where we solve either of the equations for x or y and substitute that into the other equation to solve for the remaining variable. I'm going to go ahead and choose to to substitute in for y, since this equation is already set equal to y. So what that means is the y value in this equation is the same thing as this equation. So instead of 2 times x plus 3 times y, I have 2 times x plus 3 times, what is y equal to? It's 2x minus 4. Y and 2x minus 4 are the same thing. So I can just go ahead and drop this right in place of that y, equals 12. So this that we are looking at here is the first equation, but instead of y, I've substituted what y is equal to, which is 2x minus 4. So let's go ahead and solve this. I always distribute first, if possible. So I'm left with 2x plus 3 times 2x is 6x. 3 times negative 4 is negative 12, equals 12. I need to combine like terms. So I'm going to see which of my terms are alike. I have 2 that are alike here. 2 and 6 is 8x. Now I'm going to get rid of or move over my addition and subtraction. And I'm left with 24. My last step is divide by 8. And I have x equals 3. Now that I know my x value, I need to plug that in or substitute that in to solve for my y. So I'm going to take my second equation here, which is y equals 2 times x. I know my x is 3, so 2 times 3 minus 4. So y equals 6 minus 4, y equals 2. Just to check my answer, 2 times my x value plus 3 times my y value should equal 12. So that's 6 plus 6 does equal 12. Let's check the other one. So my y value equals 2 times my x value minus 4. So that's 6 minus 4 is 2. So I have checked it. I know that this would be the correct answer. All right, then the third method was elimination. So when we do elimination, we need to multiply one or both of the given equations in the system by a number so that we can eliminate in columns by combining terms. So I'm going to go ahead. I see that we could eliminate our x or our y. I'm going to go ahead and eliminate my x's by multiplying by -2. If I multiply by -2, that's going to change this entire equation, and it's going to give me a setup where my x's will combine to cancel out. So let's see what happens. So my first equation is not changing. My second equation, I'm going to distribute a -2. -2 times -1y is positive 2y. -2 times 4 is -8. So now I'm going to combine in columns here. So 4x minus 4x, those cancel. 6y and 2y give me 8y. 24 minus 8 gives me 16. Now I'm going to go ahead and solve for y. Y is equal to 2. So I'm going to get my ordered pair set up. So when y is equal to 2, now that I know that, I can use either of these equations to substitute 2 for y and solve for x. I'm going to use my second one because it's a little simpler. So I'm going to just add 2 to both sides. Now divide by 2. I'm going to end up with x is 3. When you plug those numbers in, I'm going to just check them quickly. When x is 3 plus 6 times y is 2. So 12 plus 12 is 24. So that works with the first equation. X is 3 minus y is 2. So that's 6 minus 2 is 4. Yes, that works. So I know after checking that 3, 2 would be the answer to my system of equations there. Okay, we've got a word problem here for our systems of equations. We can choose how we want to solve it. So let's get into it. Thomas is starting a new company. He has 2 quotes from a computer company for the cost of computers and printers. Let's go ahead and say that my C will be computers and my P will be printers, okay? That way I know what variable I'm using with each of the numbers that I see. So let's look at the first sentence here. If he buys 3 computers and 1 printer, he spends $825. The next sentence, if he buys 4 computers and 2 printers, he spends $1,200. They want to know what the computers and printers cost. So given these 2 statements, these 2 equations, I can solve for the computer and the printer. I get to choose how I want to solve. I'm going to go ahead and solve by doing substitution, because when I have just one P here, if I isolate the P, I can substitute that into my other equation. So if I have 3C plus P equals 825, I can subtract 3C, and I can be left with -3C plus 825. That is what I'm going to substitute and place here for my P. So let's do that. So 4C plus 2 times -3C plus 825 equals 1,200. So what did I just do? I took my first equation, solved for P. I know that P and negative 3C plus 825 are the same thing. So I'm taking that substitute for P and I'm dropping it right in place of my P in my other equation. Now I'm going to solve. I'm going to start by distributing. So I'm going to have 4C minus 6C equals plus 1650 equals 1200. All right, so now I need to combine like terms. So 4 minus 6 is negative 2C minus 1650 negative 2C equals, that's going to be negative 450. The last step, divide by negative 2. C is equal to 225, positive 225. So computers are $225. Now that I know computers are $225, I can take that value and plug it into either of these to find out how much the printers are. So I've got 3 times 225 plus 1 printer was $825. I can plug this into either problem, by the way. So 3 times 225 is $675. And I just have to solve for P. It's going to be 150. So printers are $150. So we've got computers are $225, printers are $150. Let's go to the last page here. We're just looking at a review of the property types that we've talked about this year and identifying them. So I find it easiest to go down this side with the letters and then match it with the property that it goes with. So let's start at the top. We've got x is equal to y, and I can multiply both left and right by a, and it stays equal. That's going to be the multiplication property of equality. The multiplication property of equality says if I multiply the left side by a number and then the right side by the same number, my equation will remain equal. In B, I see that I have x times y, and that is equal to or the same thing as y times x. That's going to be the commutative property where our terms can, our values can switch places but still be the same value. So we've got commutative property of multiplication. The next one I've got x plus y plus z, and then here I've got x plus y plus z. I noticed that what's happened is my parentheses have moved places. The groupings have changed. That's going to be the associative property, and we've got addition here. Our numbers are associating with other values. That's going to be the groupings. That's the associative property of addition. Next we've got 3 times x plus y, and that's the same thing as 3 times x plus 3 times y. This is what happens when we distribute our 3. So we're looking at the distributive property. Next we've got, again, a change of grouping. I see that my grouping here is x times y, then it's y times z. So with just the change in grouping, the moving of the parentheses, that's going to be the associative property of multiplication. Next we have x plus y is the same thing as y plus x. Commutative property, my x and y's commute to another location, and with multiplication and addition, the value remains the same. Finally, I've got x and y are the same. If I add a to both sides, it's still equivalent or the same, and that's going to be the addition property of equality. Finally, we've got a proof here, and we need to solve this problem and look at the work that Thomas has done and figure out the correct reason for line 3. So let's take a look. He's got 6 times 2x minus 5 equals negative 34. Well, my first step here would be distribute, which I know we're not looking at step 3, but I would go ahead and solve that. So if I distribute, I'm going to have 12x minus 30 equals negative 34. Now my next step would be add 30 to both sides. If I added 30 to both sides, that would be negative 4. Yeah, that would be negative 4. Maybe there's a typo here. So 12x negative 30. When I add 30 to both sides, negative 34 plus 30 is negative 4. Maybe there's a typo there. But this should be the addition property of equality, because if I add 30 to both sides, so I would say your answer would be the addition property of equality. Then once you get here, we would divide both sides by 12, and we would get x is equal to 1/3. Sorry. Divide by 12, that's 4 over 12, which is 1/3. So x is equal to 1/3. I believe there would be a typo here. This should be negative 4. So maybe check with your teacher. If you're my student, I'll make sure I address this with you. But it appears 6 times negative 5 is negative 30. Add 30 to both sides. Negative 34 plus 30 would be negative 4. So, but anyways, the answer would be addition property, because I would be adding 30 to both sides. So that concludes the review portion of this. So please turn off this video and go ahead and complete the practice problems, and make sure you submit those along with these completed notes to your teacher so that you can get credit and have ample opportunity to practice and review for the end of course exam. Thank you for listening to this long video, and I'm proud of you for taking responsibility and getting this finished so you can do your best on the end of course exam. Have a great day.